Hello friends, I am Ganesh. Welcome back to my channel. So we already discussed that working principle of the robot in the last video. If you have not watched that video, I will give the link in the description. You can watch that video first, and you will get know everything. So I already explained the some of the part of the programming, and remaining will be continued now. In loop, we will declare that which pin and when it should go high and low. I'm clear? In loop, we will declare that which pin and when it should go high and low. Now, so that for the calculation of the distance using ultrasonic sensor, we have to write that digital. So for the high and low, we will use the digital write command or a function. Digital write trig pin should low. I'll explain you. We need to hide the trig pin for only 10 microseconds. Before that, we have to low that for 2 microseconds, because we will get the exact 10 microseconds high. That's why we are written that. Now I will write the variable name. We are already initialized that the variable name is a duration. Duration is equal to, we have to use a pulse in function. Pulse in echo pin. Echo pin high. See, pulse in means reads a pulse either high or low on a pin. On a pin means it is a echo pin. Pulse in command reads the pin which is high or low. Now we have to write the calculation part. I will explain with the pen and paper. Let's see how to find the distance using ultrasonic sensor. So we know that the formula is time is equal to distance by speed. Here we are going to consider this speed of sound. So we know that speed of sound at a room temperature approximately. So speed of sound, that is a 340 meter per second, but we want in a centimeter per microsecond. So convert this into centimeter per microsecond. To convert this one, so divide 340 by 10,000. So we will get answer as a 0.034. Now it is a centimeter per microsecond. So we will use this as a speed of sound. Now we know that the speed of sound and time we will get in the or Arduino will calculate the time. So we will easily find out the distance is equal to time into speed. But we have to divide it by 2. Why we should divide it by 2? See, assume it is a ultrasonic sensor. So you can see the two main components in that ultrasonic sensor. One is a trig, another is a echo. So we know that trig transfers waves, or you can say emits waves. It is an object. So trig emits the waves, and waves finds a object, and it will reflect and receives in the echo. So the Arduino calculates the time from year to year, but we need the time only from year to year, required time required. That's why we are going to divide it by 2. So we will use this formula in the program. So we will, in the place of speed, we will put the value, that is a 0.034, and time is a, we have declared in the program as a duration, that is a time, divided by 2. So that's it. Now we know that the formula, what is that formula? Distance is equal to, we already declared that, what is distance in a distance, duration into means star mark, into 0.034 whole divided by 2. We already know that. Now it is stored. Let us print that in serial monitor. Serial dot print the, let us print the message as distance, and see here, you have to do capital that. So now if you want to print the distance which is measured by the ultrasonic sensor in the serial monitor, now for the ultrasonic sensor it is completed. Now we will move to the next, that is for the higher sensors. We have to initialize some more 2 variables. We will I will take the int type, and what should be read? Write. We already know that. I am initialized the right value is equal to digital read right, and left value is equal to digital read left. We have to read that value of the right and left, which means we already know that what is right and left. Right means we have assigned the value in a initialization part. You can see left is initialized, or you can say left is connected to the A3 pin of the Arduino, and right is connected to the right sensor is connected to the A3 pin of the Arduino, that is analog pins. The higher sensors will give the signals to the Arduino, and Arduino should read that signals. That's why we are going to use the digital read. It's the function of the digital read is it will read the function, that is the right, which means right means it is connected to the A3 of the analog. When A3 receives the signals, and it will read that signal, and it will store the value in the int type, variable name as a right value, same in the left value also. So we will use that right value and left value in the next. Now let us write the conditions for the forward. Let us write forward. We know that the conditions for the forward, that is the, let us write the if statement. If, let us write if statement. If we know that already we have defined that value, right value. Let us take that value, right value, and we have to use double and now for the left value, what should be the left value? Let us guess. Yes, you are right. Left value should also high. Now I will explain you after completion of this line. Di distance should be more than and equal to 10, that is 10 centimeter. Distance should be less than or equal to, so don't put the semicolon for the if statement. Now let us explain that line. If we have to use the if statement for the condition, for this condition, I will open. So we are already assigned that value, right value. When you use the right value, it will read the right, means I already declared that what is the right. Right is right pin of right sensor that is connected to the A3 pin of the Arduino. When you use that, when you use Arduino right underscore value, the A3 pin of the Arduino will read and it will store the value in the right underscore value. When there is no detection in the IR sensors, the IR sensors will give the signals to the Arduino as a high, that is a 1. High means 1, low means 0. If the condition is what is the condition? Right value should be high and left value should be low. Left value should also be high and distance should be more than 10 centimeter or equal to or more than 10 centimeter, and distance should be less than or equal to 30 centimeter. So distance which is measured by the ultrasonic sensor, if statement become a true, what should do the robot? Now we will write that. So I already said that for the to make the pin high and low, we will use the digital write command. I will write digital write. So digital write should be a 2 and 3 input 4. It should be a low. We know that why it should be a low. When the motor driver receives the input 1, input 3 and input 4 as input 1 as a high, input 2 as a low, means left side of the motors will rotate in a forward direction. Input 3 and input 4, in input 3 will be high and input 4 will be low, means the right side of the motor also rotate in a forward direction. Now the both motors are rotating in a forward, then the robot easily move forward. Now the forward, for the forward the statement is completed. Now let us write the program for the right turn. So again we comment right turn. Right turn. For right turn, again we will use the if statement, that is after the if we will use the else if. We should use else if. So if you know the basics of the C and C++, you can easily understand the program and you can write by your own also. For the right turn, we will consider the IR sensors detection only. Now we need this line. I will copy from the so you can see I already said that for the right turn and left turn we will use only the right that is a IR sensor, that is right sensor and left sensor. When right sensor detects a object, means the output will be the 0. I already said that when the IR sensor detects any object, means it will use the signals to the Arduino has a low, that means 0, and the left sensor, there is no detection in the left sensor, that's why it is giving the high, that is high. We will write the body of this statement. The robot should take a right turn, means the left side of the motor should go forward and right side of the motor should be stationary. For a right turn, the left side of the motor should go forward. Now it is high and low. When you give a high and low, the left side of the motor will go forward. It is already correct. So now digital right, we will write it is a reverse. Now we will make in a reverse. I will explain you why it should be a reverse. Now we will now the condition will be the right side of the motor motors are rotating in a reverse direction. Why? For the quick turn, we are going to reverse the right side of the motors. Now it is completed for the right turn. Now we have to write the conditions for the left turn. So for the left turn, again I will copy from the above. Again we will use the else if statement, this if statement. Right, for the left turn, the left side of the sensor will detect the object and it will give the 0 as a output to the 0 as a output, and it will be input to the Arduino. For left turn, the input 1 and input 2 should be a reverse direction, that is a low and high, and the input 3 and input 4 should be a high low, that is input 3 is a high and input 4 should be a low. It will create the left turn. Now the robot will take a left turn. Now for the stop, say comment, and I will copy this one. For the stop the robot, what are the conditions should be there? Right IR sensor value and left IR sensor value both should be high. When both should be high, there is no detection in the IR sensors, and the both sensor will give the high signals. When there is no detection in the both the sensors, then the robot should be stopped. To stop the robot, all the value should be low. That's why I am going to make the all input value as a low. Now last we will use the distance. We will use the distance condition, that is a, I will write distance should be a more than 1 centimeter and distance should be a less than 10 centimeter, the robot should be a stop. We are going to make a like that. So we are going to make the robot stop, because from the 1 centimeter to 10 centimeter there is a small distance from the robot to the object. When we are trying to do a forward, then the robot will hit the object and it will crash. So that's why we are going to stop. For the safety purpose, distance should be a greater than 1 and less than should be a stop the robot. Will stop the robot. That is a we are copy from the above statement. That is all the inputs should be a low. So now I added some more features, that is a servo. Still I am not explained the servo, so now I will explain. I already added the program for the servo and the speed control of the robot. We can control the speed by varying these values. I will explain you. So first we have to add the servo header file. So go to sketch and include library, go to manage library, and you will find the search bar. Okay, wait some second. So now we will search here servo. So just type servo. Now wait a second. So now here, so here it is servo. So I already installed that, that's why it is hidden. So if you are not installed this one, so install this header file. So after this, okay, close. So after downloading this header file, go to sketch, include library, and just you will find this servo. So click servo. So the system will automatically include this line. So now it's already added, that's why I am deleting this one. So now servo is the data type, that is the servo. So my servo is the variable name, and we have taken one more variable name as a position, that is a POS. We have initialized that value equal to 0. 0 means it's a 0 degree. So now, so we will get in the next line, so that clear picture. So we have to define two more names, that is a so we have to define two more pins, that is enable 1 and enable 2. So we'll find two pins in the motor driver board. So enable 1 pin is connected to the 11th pin, enable 2 pin is connected to the 12th pin. So we will using by using the enable pins, we will control the speed of the motors. So now we have to create a two more variable called m1 speed, m2 speed, that's a motor 1 speed and motor 2 speed. I have assigned the value as a 128 to the both the variables. It is a pulse width modulation value. So if we change this value to 255, it's a maximum value. It's a maximum value. If the value is 255, then the motor driver supplies complete, that's 100% voltage to the motors what you have given to the motor driver board. So if I change it to this value to 128, this is a 50% of the 255. So that's why the motor driver board will supply the voltage 50% what you have given. Keep the both the value same. So now in the setup for a servo, some more lines for the servo motor, that is a my servo. I already initialized that my servo dot attach. We have to write like this, my servo dot attach. It is a connect to the 8th pin of the Arduino. So servo motor has a 3 pins. One is a GND, and one more is a VCC, and the final one is the signal pin that is connected to the 8th pin. So that is a yellow color pin, yellow color wire is there in a servo. So you can connect that to the 8th number of the Arduino digital pin. So now we return a 3 for loop statement. So if you know the for loop statement, then you will easily understand this, guys. If the position is 90 degree, then the position will increase by 1 degree and is equal to or less than 180 degree. When it's come to 180 degree, again the for loop condition, position is 180 now, then the position will decrease by 1 degree and position will be equal to final equal to 0. Now it is in a 0. So now it is 0. Now it will increase the by 1 degree and up to it will stop at the stop to the 90 degree. So this is what the for loop condition setup. We have to declare 2 more. There is already initialized that enable 1 pin, enable 2 pin, that both are the output. Now in a loop, just 2 lines we have to add, that are the analog write enable 1 M1 speed, analog write N2, so En2 M2 speed. We have to add 2 more lines to the forward, right turn and left turn. So now it is completed, the program is completed. So I will give the link in the description box, so you can download it and you can cross check with your written program if got any error. So now the video is completed. Still, if you are not subscribed to my channel, subscribe now. Okay, we will meet in the next video. Until then, take care, bye bye.